Hello everyone and welcome back to the world of finance. Now in this class we are going to get started with a wonderful discussion, and that is all about forward rates and forward rate agreements. FRA, forward rate agreement. So we are going to observe the applicability of this topic in subjects like fixed income, and more importantly in subjects like derivatives. So what exactly is a forward rate? See, you want to borrow, okay, or you want to lend money. Borrowing or lending, but not immediately, not at the spot. You would want to borrow or lend for a certain period, but not now, at a later date. But then what is happening now? At present you are just fixing the rate of interest. So forward rate is a rate which is agreed today, but it is applicable for borrowing or lending that will initiate after a certain time for a certain period. Now here we have two major classifications: long term FRA and short term FRA. What is this FRA? First of all, FRA stands for forward rate agreement. So when I say what is a forward rate is a rate which is agreed today, but it is applicable for borrowing or lending at a later date. So when I say a rate which is agreed today, means you have entered into an agreement with a counterparty. If you are borrower, the counterparty will be lender. If you are lender, the counterparty will be obviously borrower. So you are entering into an agreement for borrowing or lending at a later date. That agreement is called FRA, forward rate agreement. Now, forward rate agreements can be used for either hedging or for speculative purpose as well. So the speculative or hedging aspect we will be talking about at a little later stage. What we will begin with is how to determine these forward rates. Beautiful concept. And as I said, when we have any given spot rate, we should be able to arrive at the implied forward rate. But a singular spot rate won't work. You need a set of two different spot rates at least to arrive at implied forward rate. But let me not create any confusion for you. We are going to go systematically to approach this topic and make it easy going for you, and we will be reaching to heights where any question, any complexity coming on your way, you will be able to crack it easily. So let's begin with what exactly is the meaning of forward rate and forward rate agreement. So as I already mentioned, and I believe you would have already written this title in your notebooks by now. So we are getting started with what is the meaning of forward rate. A forward rate is an interest rate which is agreed today for a loan to be made at some point in future or at some future date. The annualized interest rate on a loan to be initiated for a future period is called the forward rate for that period. Now see, there will be two different periods involved. One is the waiting period and one is the loan period. For example, I want to borrow after 1 year for a period of 2 years. So total timeline, if I draw, I start at 0 year, that is now, and the first point in that timeline will be year 1, means the loan is going to initiate in year 1, and the loan is going to be for a period of 2 years. That means the loan will terminate at 3rd year from now. Why did I say 3rd year from now? Because loan will initiate after 1 year and loan will be for a period of 2 years. So 1 plus 2, loan will terminate at 3 years from now. So loan will start at 1 year from now, loan will terminate at 3 years from now. So loan will be from the period 1 to 3, that will be for 2 years. Now what happens? I told you that we may have two categories of FRA, the long term FRA and the short term FRA. See, conceptual understanding is common for both. The way you compute the implied forward rates from the given spot rates or from the given market reference rates, it is common for both. What is the difference? Within a short term FRA, we will say something like this, that I want to borrow for 3 months after 2 months from now. Means after 2 months from now the borrowing will initiate, and the borrowing will be for a period of 3 months. So when the period of borrowal is a shorter period, it is a short term FRA. When the period of borrowal is a longer period, it is long term FRA. So short term FRA, long term FRA, point is very clear. Anything under 12 months comes in the short term category, anything beyond 12 months will come in the long term category. Mathematically, what kind of difference it would make? For example, if it is a long term FRA, then compounding on annual basis will happen. However, if it is a short term FRA, then it is implied that you are referring to the market reference rates which are to be adjusted periodically. For example, if annual rate is 12%, then if you want to borrow for 3 months, it will be 12% into the time factor, that is 3 by 12. So 3 by 12 becomes a time factor, because 12% is for 1 year. How much for 3 months? So it will be 12% into 3 by 12. That time adjusted rate will be considered in both cases, but when you are going with long term FRA, it will be the time adjusted rate which implies the factor. So we know one thing, when we are going for a long term period, annual compounding will happen, and the factor will always be considered as 1 plus rate to the power t. T will be the number of years, or you can even write it as 1 plus I raised to n, where I indicates the annual interest rate and n is the number of years. It all depends on how comfortable you are using with which variable, okay. But most important thing is the conceptual understanding should be very clear. Now what happens? We have seen the yield curve concept. So when you are plotting forward rates in a kind of term structure, means graphically you are trying to plot forward rates for year 1, 2, 3, 4 and so on. When you are indicating the term structure of interest rate in the format of forward rates, the curve that you get, and obviously you are not going to get a straight line, the curve that you get is called the forward curve. So forward curve indicates the term structure of interest rates when it is a forward rate. So let me give you a couple of lines on forward curve as well, and I would want you to write these notes over here, and once you are done with writing these notes, we will move ahead. Alright friends, I am sure you would have completed writing this whole thing. Now, as I said, the term structure of forward rate, you will be getting it graphically in the form of a forward curve. So a forward curve presented graphically is the indication of the term structure of forward rate. I already told you that. Now the last line, when you were writing these notes, you would have seen that spot rates and forward rates, they are connected mathematically, and therefore if I give you information about a set of spot rates, you can derive forward rate out of that. Likewise, if I give you information about forward rates and maybe 1 or 2 spot rates, you can find the other spot rate. They are mathematically connected. How they are connected and how to derive one from the other, we will be observing that through a logically derived equation, and sooner we are going to get started with those calculations. But conceptual clarity is utmost important, and what I want you to understand over here is, spot rate and forward rate, what is the difference between that? Suppose you want to borrow or lend money now. You want to borrow now, the applicable rate will be spot rate. You want to borrow, but you want to borrow at a later stage, the applicable rate will be the forward rate. That's it. So you want to borrow now, it will be spot rate that applies. You want to borrow at later stage, but you want to fix the rate now, then it will be forward rate. Now, the terms and variables that are used over here, you should get familiar with that, and you should not ever have misunderstanding with respect to that. So please focus on this timeline. Here I have plotted 4 years starting from 0 and then year 1, 2, 3, 4. Now let's say you want to borrow for this period. Observe this period. When does it start and when does it end? Your borrowing is supposed to start at year 1 and your borrowing will terminate at year 3. Borrowing will be for what period? Borrowing will be for a period of 2 years. Now fact number 1, are we talking about borrowing in certain days or months, or are we talking about borrowing in terms of certain number of years? It is certain number of years over here. As a result, it's beyond a 1 year period that you are considering to raise borrowings. It's a long term FRA. Now, symbolically, how do you represent this? You will call it F1, 2. Now, F as in small f is used to indicate a forward rate. Capital F is used to indicate a forward price. So we are purposely using small f over here, and you should always follow this discipline. Small f indicates a forward rate. Now what is the relevance of this 1, 2? After 1 year the loan will start, and loan will be for a period of 2 years. And how do you call it? 1 year forward. Means the waiting period is 1 year. From 0 to 1 year you will just wait. Rate you have fixed today, but your borrowing will initiate at year 1. So 1 year forward, 2 year rate. Means the rate is applicable for a 2 year borrowing. So annualized rate which is applicable for a 2 year borrowing will be called a forward rate. Now there can be set of multiple forward rates. Which forward rate you are talking about? Is it for borrowing that starts after 1 year for a period of 2 years, or borrowing that starts after 1 year for a period of 3 years, or borrowing that starts at second year and for a period of 2 years? You have to mention that using this pattern of symbol. So F1, 2 indicates that borrowing will initiate after 1 year. We call it 1 year forward, and borrowing will be for a period of 2 years. Let me ask you one question. If this is the period of borrowing which starts at second year and ends at fourth year, symbolically, how would you name it? Maybe I'm not able to get your answer other than those who are attending the class online. So if you are just watching this recorded video, before I display the answer, think over it and keep your answer ready. Based on what I see from students attending online, yeah, most of you are correct. Very good. It will be a 2 year forward 2 year rate, and it will be symbolically presented as small f2, 2. So small f2, 2 indicates that borrowing will start after 2 years and it will be for a period of 2 years. Even though this is something very small and simple, but I would want you to still note it down for your reference. Alright friends, I am sure you have done this. Now most important thing, if I just ask you to identify the forward rate for this period which I have marked, what you would formally call it as. So the loan starts in year 1 and loan will terminate in year 4. So you will call this as what? You will call this as F1, 3. That is loan starting in 1 year and loan will be for a period of 3 years. So F1 comma 3 should be formally read as 1 year forward, 3-year rate, means whatever be the rate that you are going to compute over here, or that you are going to determine or specify over here, will be the rate applicable for a 3-year borrowing from end of year 1 to end of year 4. The period of borrowing will be 3 years. What about this one? So obviously, how should you see? It is starting at end of 3rd year and ending at end of 4th year, means loan will be only for 1 year. That means the rate will be a 1 year rate, and it is starting after how many years from now? 3 years from now. So you will formally call it as a 3-year forward 1 year rate. And symbolically, can you again try? What will you resemble that symbol as? Small f, what comma what? It will be small f 3 comma 1, and that indicates 3-year forward 1 year rate. So again, I'll give you a minute to write down this timeline, and then we move ahead. Alright friends, I'm sure you have completed this as well, and now what we do is we formally write down these symbols. So consider the following notation. Now look at this notation. We are saying f j comma k, small f j comma k. So j is the waiting period and k is the period of loan. So if we draw the timeline, we always start with 0 year, so t equal to 0. Here it is t equal to j, means loan will initiate at j year. So from 0 to j it is the waiting period, and from here to here it is the loan period which we are calling as k. That means from 0 to j it is j years, and from j to the end it is k years. So if this is k and this is j, obviously the total time will be j plus k. So mathematically, if I write f2 comma 3, so in j comma k format, 2 comma 3 would mean loan will initiate in 2 years and loan will be for a period of 3 years. But the rate will always be the per annum rate, that is the annualized rate. That is why f2 comma 3 is mentioned as the annualized interest rate applicable on a 3-year loan, because loan is for 3 years. So it is applicable for a 3-year loan starting in 2 years. Likewise, when you mention it as j comma k, it will be the annualized interest rate applicable on a k year loan starting in j years. And when I draw this timeline referring f2 comma 3, so loan will start in 2 years and loan will be for a period of 3 years. So by the time the loan terminates, the end period from now will be 5 years away. So we mention this as t equal to 0, t equal to 2 and t equal to 5. So sometime back I was telling you that mathematically spot rates and forward rates are connected. So here let me give you one simple straight logic. If I want to identify f2 comma 3, it will start at which year? 2 year. It will terminate at which year? 5 year, because loan is for a period of 3 years. That means if I want to find the implied forward rate, that is implied forward rate as f2 comma 3, I must have the spot rate for 2 years as well as the spot rate for 5 years. So between spot rate for 2 years and 5 years, I will be able to extract mathematically what is the implied forward rate applicable for a 3-year loan that will start after 2 years. That is f2 comma 3. When we arrive at this implied forward rate, and if the actual rate does not match with that, the market is going to provide an arbitrage opportunity, because when we are making all these calculations as implied forward rate, it is basically a no arbitrage kind of rate. If the actual rate differs from that, definitely there will be an arbitrage opportunity. So what we do over here, we will just take a moment to write down this, and once you finish writing this, we will move ahead. Alright friends, once you have completed writing this, let me now get started with an example. I want you to focus on this timeline again, where we are talking about interrelationship between spot rates and forward rates. To make things simple, I have drawn the timeline just for 2 years. So 0, 1 and 2. Now this is a rate given as 6%, and can you notice through the timeline what is the applicable period over here? It starts from 0 year and it terminates in 1 year. Means it is a 1 year loan starting now. When it is a 1 year loan starting now, it cannot be a forward rate. Starting now has to be spot rate. That means this is definitely 1 year spot rate. Now we symbolize spot rates as either S1 or Z1, all depending upon what kind of variables you prefer using. So S1, S2, S3, S4 are symbols that we use for spot rates. So S1 indicates 1 year spot rate, that means annualized interest rate for 1 year loan starting now. S2 represents annualized spot rate for a 2 year loan starting now. S3 represents annualized spot rate for a 3 year loan starting now. So when it is a spot rate, it has to start now. S1, S2, S3 are symbols used for spot rates. Alternatively, you may use Z1, Z2, Z3, Z4, etc. for spot rates. Why Z coming into picture? Spot rates are also known as zero coupon rates. That is why Z1, Z2, Z3, etc. can be used as symbols for spot rates. So here I have mentioned 6% as that spot rate for 1 year, and the other rate that I am mentioning, it is 8%. But look at one thing, that 8% is the rate applicable from year 1 to year 2. This is not a spot rate, correct? It is definitely a forward rate. It is starting after 1 year and it is for a period of 1 year. Means it is 1 year forward 1 year rate. So this 6%, as I said, it is Z1, and this 8% is F1, 1, means 1 year forward 1 year rate. Now let's say that at 0 year, at present, I borrow $1,000. If I borrow $1,000 at present, correct, what happens in 1 year time? If I have to repay in 1 year, how much money I will repay? I will have to repay how much? $1,000 plus the interest for 1 year. 1 year interest is 6%. 6% of $1,000 is $60. So the maturity value of this borrowing at end of 1 year will be 1,060. But suppose I continue with this loan for yet another year, then the applicable rate will not be 6%. If I continue with this loan for yet another year, the applicable rate from here to here is 8%. That means the base value now, see why compounding will happen, because this much interest is already accumulated. So $60 of interest already added to the principal. The adjusted principal outstanding is $1,060. Assuming no interest is paid over here, this loan is stretched for 1 more year, but now the applicable rate will be 8%. So obviously what you are going to do, you are going to apply 8% rate, and that 8% rate applied on this will make it $1,144.8. How did I get that? $1,060 multiplied by 1.08. So 8% is the applicable rate for the second year. The factor for the second year becomes 1.08. So logically, how did you reach here? How did you reach here? From here, 1000, you multiplied 1.06, you got 1060. To that 1060, you again multiplied 1.08 and you got 1144.8. Now, we have connected from year 0 to year 1 and then from year 1 to year 2. What if I directly connect from year 0 to 2? Then today's $1,000 will become $1144.8 in 2 years time. this rate will be the rate applicable for 2 years, but that will not be a forward rate, that will be a spot rate because it is starting now. And symbolically, if this was Z1, then this will be Z2, and the factor that connects from 0 to 2 years will be 1 plus Z2 raised to 2, because 2-year factor compounding is happening on annual basis. So 1 plus Z2 is the factor for 1 year, 1 plus Z2 becomes a factor for other year, because Z1 and Z2 are different. Z1 was applicable for first year, Z2 is applicable for a 2-year loan. So both years the factors will be 1 plus Z2, 1 plus Z2. In other words, it is 1 plus Z2 whole square. So 1 plus Z2 whole square. Now you need to connect 1000, 1 plus Z2 whole square as a factor, and this part $1144.8. When you connect these three, you will get an equation from which you can arrive at Z2. So what I am trying to tell you, Z1 was given, F1 comma 1 was given, what was missing? Z2. You can compute Z2 mathematically. Alternatively, if I would have given Z1 and Z2, you would have computed F1 comma 1. If I give you Z2 and F1 comma 1, you can find Z1. Out of these three, any two variables informed, the third missing variable you can derive through this mathematical connect. And gradually we are going to arrive at an equation which we will name as, not we will name as, the world has been naming that equation as a forward rate model historically since it was developed long back. So forward rate model is what we are going to derive out of this logic. But before I take you ahead, I would want you to note down this example right now. Alright friends, once you have completed this whole thing, let me now take you ahead. So what I am going to do, to $1000, if we multiply 1 plus Z2 raised to 2, we must be getting $1144.8. This is the equation that we are going to establish now. Look at this, look at this. $1000 into 1 plus Z2 the whole square will give you 1144.8. So in this equation, do you observe that there is only one missing variable, that is Z2. You solve this equation and you get the value of Z2. So 1 plus Z2 the whole square will be 1144.8 divided by 1000, and when you solve it, what you get is 1.1448 as the value of 1 plus Z2 raised to 2. So if I want to find 1 plus Z2, I have to take the square root of this, correct? Because 1 plus Z2 whole square is this. That means the root value 1 plus Z2 has to be square root of this. So 1 plus Z2 will be square root of 1.1448. When we do that, we get 1.069953. We can find it very close to 1.07. So intentionally I am writing this 1 plus Z2 is not exactly equal to, but approximately equal to 1.07. So we have used a bit of approximation. If you want to avoid approximation, you want to get it with all decimal places, you can please write 1.069953 as the proper rate. Here allow me to take an approximate value as 1 plus Z2 approximately equals to 1.07. So Z2 will be 1.07 minus 1, Z2 will be 7%. So notice one thing, from year 0 to year 1, the applicable rate was 6%. From year 1 to year 2, the applicable rate was 8%. So actually 6 and 8 taken together, it is 14%. So you are actually giving interest of 14% combined 2 years. So on an average each year it will be 7%. Now that average is not the right approach, correct? But as a hint, you can get one point very clear, that Z2 what we just found was the average of 6% and 8%, correct? So if you want to get close value, you can take this kind of average to get an approximation, but this is the real way in which you need to make the computation, because compounding cannot be ignored. So I'll give you a moment to write down this whole thing and then we move ahead. Alright friends, so once you have completed this whole thing, now let me explain to you yet another very important matter. Now see, if you focus only on this equation, let me first remove this other part, just a moment. Yeah, focus only on this equation now, and if you can see, how did we get this 1144.8? If you can recollect, this 1144.8 we actually got by taking 1000 into 1.06, which became 1060, and to 1060 we multiplied 1.08, so we got 1060 into 1.08 as 1144.8. That means this can be rewritten as 1000 into 1.06 into 1.08, correct? So what I am doing, I am writing 1 plus z2 the whole square equals to, logically it should be 1144.8 divided by 1000, but instead of 1144.8 I am writing the origin point of that as 1000 into 1.06 into 1.08. At any point of time, mathematically, if you multiply these three, obviously you are going to get this. Now, why I am doing all this? From this term in the right hand side, we can cancel out this 1000 and 1000. So eventually, what is 1 plus z2 the whole square? It is 1.06 into 1.08. If I now use the symbols, 1 plus z2 the whole square is 1 plus z1 raised to 1 into 1 plus f1 comma 1 raised to 1. So if I want to arrive at forward rate, that is computing or determining the implied forward rate from given set of spot rates, we apply forward rate model. The forward rate model relates the forward rates and spot rates as follows. I am using this same logic to arrive at this equation. Now look at this. F1 comma 1 means 1 year forward 1 year rate, means J and K both were 1 year. So this was the short period, that is the shorter term factor, 1 plus z1 raised to 1. This was the longer term factor, that is 1 plus z2 raised to 2, because in that timeline 0, 1 and 2, correct? From 0 to 1, 1 year period. From 0 to 2, 2 year period. So what is the factor for 2 years? 1 plus z2 whole square. What is the factor for 1 year? 1 plus z1 raised to 1. So if I want to consider this equation, look at this. 1 plus z2 whole square is 1 plus zj plus k, because j was 1 year, k was 1 year, so j plus k combined 1 plus 1 is 2 years. Raised to j plus k means raised to 1 plus 1, which is going to become 2. Then 1 plus zj raised to j. So zj, j was 1 year, so 1 plus z1 raised to 1, and 1 plus fj comma k means 1 plus f1 comma 1 raised to k. K was 1 year, so raised to 1. This is the forward rate model equation. So at any point of time, you want to connect the logic of forward rate model, that is logic of this equation, you need to refer to this particular example that I have discussed with you. See what happens when you are approaching questions with a faster pace, with a quick application of logic, you sometimes forget the original derived logic, and that is where that original logic should always be there clear in your mind. I'm not asking you to apply the details of those logics every time when you solve the question. Definitely not in the examination, because in the examination your battle is against the time, correct? So you have to be very, very quick, you have to be accurate. But when you are learning, when you are practicing, when you are revising, your fundamental concepts should be unshakable. It should be so strong that nothing can impact it adversely. So the foundation has to be built with that clarity of logic. On top of that, you build layers of shortcuts and formulas and equations through which you can solve questions quickly. So in this topic, all the lectures that are coming forward in that series, if you watch each of these, believe me, by end of the series you will become expert in dealing with this kind of scenario. So solving any complicated question with complete accuracy, without wasting a moment, in as short time as possible, this is doable once you are done with this entire series. So let's just first write down this content what you find on screen, and then we move ahead. Alright friends, once you have completed writing this whole thing, so summarizing the forward rate model, it goes this way. Fj comma k is the annualized interest rate applicable on a k year loan starting in j years. So in this timeline, this waiting period is what we symbolize as j, and the loan period is k years. So t equals to 0. The point at which your loan starts is t equal to j, and the point where the loan terminates will be aggregate of both of these periods, so that is t equals to j plus k. So in the forward rate model, I am writing that same equation, but mostly when we are going to apply this equation to find the implied forward rates, means ultimately the objective will be to find fj comma k. To do that, in this equation, think what modification will be required. You take 1 plus z j plus k raised to j plus k as the longer term factor, divide that by 1 plus zj raised to j, that is the shorter term factor. So you take it this way, 1 plus fj comma k raised to k will be 1 plus z j plus k raised to j plus k, that is the longer term factor, divided by 1 plus zj raised to j, that is a shorter term factor. So what I always ask students to do over here is to consider this quick approach. So you have say 5 years and 3 years. Let's take an example, 5 years and 3 years. So you want to find the forward rate from third year end to fifth year end. So that will be a 2-year loan starting in 3 years. That means you want to find f3 comma 2. For that you need z3 and you need z5. So common sense applies. Z5, what will be the factor? 1 plus z5 raised to 5, the bigger term factor, the longer term factor. What will be the factor for the 3 years? It will be 1 plus z3 raised to 3. So the longer term factor divided by shorter term factor. So 1 plus z5 raised to 5 divide by 1 plus z3 raised to 3. When you do this, you will be getting the factor for 2 years. Don't forget to take the square root of that, because that is the factor for 2 years, means it will be the value of 1 plus fj comma k. So in our case it was 1 plus f3 comma 2. So f3 comma 2 means the loan is for 2 years, so the power will be raised to 2. So you take the square root, and after taking the square root you subtract 1, you will be getting fj comma k. So mathematically we are going to do that later with every question, and I am going to extend this particular logical approach once again in one more example, and thereafter it will be series of practice questions coming back to back. So let us first write down what we find on screen over here. Alright friends, once you have completed writing this whole thing, now let me take yet another example to clarify this point. We are still talking about the interrelationship between the spot rates and forward rates. So it is a timeline where I have taken 0, 1 and 3. Now before I even take you ahead, you yourself try to visualize that what we are trying to achieve. Obviously this is a 0 year, loan will start in 1 year and loan will terminate in 3 years, because we are talking about a forward rate, means we are not going to borrow now, we are going to borrow after a certain period for a certain period. So borrowing will happen at this point, because this is J, okay, this is T equal to J and this is T equal to J plus K. That means J year is the waiting period, so J year will be 1 year, and 1 to 3, that will be a 2-year gap for which the loan indicates a 2-year loan. So it is a 2-year loan that will start after 1 year, means it will be F1, 2. That F1, 2 is the applicable rate between year 1 and 3. So what 3 variables you need to have to formulate the equation? You need Z1, 1 year loan rate. You need Z3, 3-year loan rate, and then you need F1, 2. So out of these 3, if I inform you any 2, you use the equation of forward rate model and derive the missing one. So let's see what all is available. This rate is available, that is 0 to 1. That means Z1 is available. This is also available, means F1, 2 is also available. So Z1 is available, F1, 2 is also available. What is missing over here is Z3. So let's take another situation. We take the same initial principle of $1,000. In 1 year time, it will become $1,060 by applying 6% interest. So principal amount 1,000, loan period 1 year. So spot rate is 6% for 1 year. So 6% added, the factor becomes 1.06. So it is 1.06 raised to 1 actually. So 1.06 multiplied to 1000 becoming 1060. From here to here the rate is 8%, but 8% is per annum, but the gap is 2 years. So the factor will not be 1.08, factor will be 1.08 squared. So to 1060 I am multiplying 1.08 squared, I am getting 1236.384. So 1000 and this value when connected, we are connecting from 0 to 3 years. Whatever is connecting from 0 year to 3 years, it has to be spot rate. That means the connecting factor will be 1 plus Z3 raised to 3. Now with this you just need to find Z3. So what I am asking you to do, you will take a couple of minutes to write down this. Take 1 extra minute. Please take 1 extra minute. And in case you are not done with that, you can pause the video, and before you play it further, I would want you to put effort to find Z3 on your own. Even if you go wrong, not a problem, but if you go correct, believe me, that understanding will go much deeper, because you yourself made that calculation. And if you can go correct on your own, you don't need my help any further. So let's just take note of this. So write this and take 1 extra minute and compute Z3, and then only we proceed ahead. In case the video is moving ahead, you can pause it, do the calculation, and then only proceed ahead. So start your work now. Alright friends, I am sure you have completed writing this whole thing. Not just completed writing what is appearing on screen, you would have even determined the value of Z3, and I am hoping that you should have got it correct. So those who got Z3 value as 7.3292%, which I can see on screen from the students attending online, yes, most of you have got that answer accurately. 7.3292% is the correct answer for Z3. Now in case you couldn't get it, let me guide you once again. three things we need to connect. That is 1000, this factor 1 plus Z3 raised to 3 and 1236.384. Very simple. This is the present value, this is the future value. It's all about time value of money. This is 1 plus I raised to n. I over here is the spot rate for 3 years, symbolized as S3 or Z3. So 1 plus Z3 raised to n, n is 3 years, so 1 plus Z3 raised to 3. When that factor multiplied to the present value, you will get the future value. So the equation gets formulated this way: $1000 into 1 plus Z3 raised to 3 should give you this value, that is $1236.384. So if I want to find the value of 1 plus Z3 raised to 3, it will be 1236.384 divided by 1000. That will make it 1.236384. Now what is 1.236384? It is value of 1 plus Z3 raised to 3. I want to find 1 plus Z3 value. So 1 plus Z3 will be the cube root of that factor, that is 1.236384 raised to 1 by 3, means cube root of that value will give you the value of 1 plus Z3. Once you get that value, subtract 1 from that and you will get Z3 value. Let me show you mathematically how these are connected and how to solve it. This is the equation that I was talking about. So 1 plus Z3 raised to 3 will be 1236.384 divided by 1000, that gives you 1.236384. So 1 plus Z3 will be the cube root of that, and when you take that cube root, that is 1.236384 raised to 1 by 3, what you get is 1.073292. So subtracting 1 from that, you will be getting the Z3 value as 0.073292 or 7.3292%. So 7.3292% is the correct answer. So quickly take note of this in case you haven't done it yet. Alright friends, once you have completed this as well, let us move ahead and we now actually talk about what we identify as implied forward rate. Now what is implied forward rate? So now if I give you Z1 value and Z3 value, you should be able to arrive at F1, 2. That was the case over here, correct? So in this case, if I give you Z1 and Z3, so Z1 was what, 6%, Z3 is 7.3292%. If these two values were given, can you arrive at the forward rate which is going to start after 1 year and for a period of 2 years, that is F1, 2. Let's look at the equation. So implied forward rate as per forward rate model. This is the same forward rate model equation. J and K are the symbols used, but in our case it is this. So 1 plus Z1 raised to 1, 1 plus Z3 raised to 3 and 1 plus F1, 2 raised to 2. We actually want to find this value, correct? We want to find this value. So if I substitute all the given values, assuming that Z3 is given to you as 7.3292% and Z1 is given to you as 6%, you need to find F1, 2. So basically F1, 2 added to 1 raised to 2 will be the factor. So this is the factor for 2 years, 1 plus F1, 2 raised to 2. Now this will be what? The longer term factor, 1 plus Z3 raised to 3 divided by shorter term factor, that is 1 plus Z1 raised to 1. So I always say that the bigger factor divided by the smaller factor. Keep this thing in mind very clearly. Bigger factor divided by smaller factor. Now this is a factor for how many years? This is a factor for 2 years. So don't forget to take the square root to get the root value, that is the implied 1 year factor, and from that implied 1 year factor, when you subtract 1, you get the implied 1 year rate. That is the annual rate, correct, which will be symbolically F1 comma 2. So it's basically a 2-year rate, but you are expressing it as a per annum rate. That is why taking the square root is important over there. So 1 plus F1 comma 2 will be square root of 1.1664, that gives you 1.08, and F1 comma 2 will be 0.08 or 8%. In fact, when we started this example, we already knew that the applicable per annum rate from year 1 to year 3, that is F1 comma 2, is 8%, and knowing that, we computed that Z3 as 7.3292% per annum. But here I have altered the scenario by assuming that Z1 and Z3 are given, and F1 comma 2 we have to determine through this forward rate model. So what did we do? Bigger factor divided by smaller factor. Bigger factor was for Z3, that is 1 plus Z3 raised to 3, divide by smaller factor. Smaller factor was with respect to Z1, so smaller factor was 1 plus Z1 raised to 1. When you do this fraction calculation, don't forget that it is a factor for 2 years. So take the square root, then subtract 1, and you get F1 comma 2. So this is how you are going to proceed ahead. What I am going to do, just for making sure that you are absolutely clear with the concept, I am taking one more calculative example just for your reference. So before I take that one more example, in case you want to take note of this, quickly take note of this, and then we move ahead. Alright friends, so now the objective is very clear. We want to take up a calculative example just for assuring that without my help you are able to make the calculations. So here is that example. So I have given you 1 year spot rate Z1, 3 year spot rate Z3. So 7% is the annual spot rate for 1 year. 9% is the annualized spot rate for 3 years. Now with these two, obviously you are going to connect 1 and 3, means the loan will start after 1 year and the loan will terminate in 3 years. Means what you are going to find out is an implied forward rate, that is F1 comma 2. That is the question precisely asking you. Calculate the forward rate applicable for a 2-year loan to be starting in 1 year, that is F1 comma 2. Now this is what exactly we did in the earlier example. So what I am going to do, I'll first give you an opportunity to do this calculation. I'll give you some time to make the calculation. In case you fall short of the time, you can pause the video before you arrive at the calculation. But before you check the solution that I have provided, you must make that calculation. You at least try to make that calculation from your side, and I'm giving you that time over here. Alright friends, I believe you must have got the correct answer. So let us check the answers. So as per forward rate model, this equation you don't have to as such write. So you always have to take the bigger factor divided by the smaller factor, and when you get the resultant factor, it will be the factor applicable for 2 years because it was a 2-year loan starting in 1 year. So you need to take the square root of that to arrive at the implied factor for each year. That implied factor, subtract 1 from that, and you get the annualized rate for a 2-year loan starting in 1 year, that is F1 comma 2 should be 10.01% per annum. In case you haven't made this calculation, I am giving you a moment. You write up this calculation and then I take you ahead. Alright friends, I am sure you are done with this. Now please listen to me, something very very important. In this topic FRA, in this particular class, that was the first part, we have dealt with the long term FRA. That means we have dealt with situations where the loan period was longer than 1 year. We are also going to deal with short term FRA, then the speculative situations and hedging situations with FRA at later stages. So there will be multiple parts of this concept. Now, some students need practice. Some students are so clear that they can practice on their own, they don't need my guidance. So what I have done, this part 1, which is about to end now, the follow-up part, that is part 2, will be just the practice of part 1. Nothing new over there, just practice questions. So if you want, you can skip that part and directly start with part 3. If you want to go for practice, definitely go ahead with part 2. So in this entire sequence, where in the description below I have given the links of all the parts, I would want you to systematically deal with each part one by one, depending on you want to practice or you want to just go ahead and follow up the concepts, up to you. So I have given everything at your disposal. You are smart enough to understand how you want to utilize whatever resources are available for you. So that was the end of this discussion. Thank you very much for attending this class.